but also do so with extreme flexibility.
Historically, we really had a choice between coverage or capacity. With Viasat-3, you don't really have to choose.
Its capabilities are certainly considerable. Viasat-3 really represents a pretty unique way of thinking about satellite communications. One of the things we were really emphasizing, besides just the enormous amount of throughput, was flexibility.
The power of Viasat-3 is driven by innovations in ground systems and payload design.
Everything was designed, engineered to work together as a seamless system. In fact, most of the complexity in the system is on the ground, not in space. And that allows us to devote more of the size, weight, and power to satellite-specific items that can help us increase the overall system performance.
When we designed Viasat-3, we were really looking for something that would create unique differentiators for us in all of our business areas.
This work and innovation is rooted in our mission to bring more to our customers around the world.
Airlines are generating demand everywhere in the world. Viasat-3 satellites that allow you to match the demand in any one spot. No matter what the platform is, we've got our Amara product in commercial aviation. We've got JetXP in business aviation.
It's a really important upgrade opportunity and transition path to bring even greater capacity, building on the managed, highly reliable service that Nexus Wave presents.
All of these requirements are why we built Viasat-3 the way we did. For government, that's increasing the resiliency and the reliability for our users.
Today's launch and the Viasat-3 technology on board pave the way for our upcoming launches, for the future of Viasat satellite technology, and for our mission to deliver more.
Just as important to Viasat is the ability to scale the basic Viasat-3 technology, as well as the improvements we're already making to it for the next generation of satellites, both at GEO and at LEO and all orbits in between.
Thanks to all our partners that have made it possible. Thanks again to all the employees everywhere around the world that have put in just the incredible dedication to get us here.
We do have an update. The Atlas launch team is working a technical issue. Troubleshooting is underway and we will keep you posted. You know, Abby, one of the cool things about working at ULA and the launch provider in general is the ability to interface with so many different disciplines. You know, one day you could be working with a thermodynamics engineer, learning about Stefan Boltzmann and radiation, and the next day you could be working with an electrical engineer, you know, learning Maxwell's equations and radio frequency and how all that works. It's really an exciting experience.
And even more exciting is the fact that that breadth and depth of knowledge doesn't just stop with our engineering teams. We have very talented technicians and machinists who help build the rocket, along with subcontract administration folks who help procure all the rocket parts. And that's just a small look into the huge team we have all supporting this one launch.
Yeah, and you know, we have such a wide variety of ways of thinking with, you know, our launch headquarters in Denver, prop shop in Pueblo, Colorado, our launch sites both here at the Cape and in Vandenberg in California, and our factory in Decatur, Alabama. Right now, we're taking a live look at the Atlas V rocket on the launch pad. As the countdown continues, our team is taking the final steps in preparation for liftoff. The first stage, also known as the rocket's booster stage, is that bottom half of the vehicle that by volume is mostly comprised of two large tanks. The top one is filled with liquid oxygen and the bottom one filled with RP-1 fuel. Liquid oxygen is a super cold propellant, so that coldness forms a thin layer of ice around the outside that gives that tank its frosty white appearance.
Atlas is also equipped with the Centaur upper stage, which drives the payload during the second phase of flight to its final orbital destination in space.
मेरी स्कूलिंग पंजाब के कई छोटे-छोटे टियर 3 सिटीज़ में हुई। पापा गवर्नमेंट जॉब में थे, तो स्कूल हर 2 से 3 साल में चेंज हो जाता था। और जैसे ज़्यादातर स्मॉल टाउन्स में होता है, वहाँ एक ही बात बार-बार सिखाई जाती है। मैथ्स और साइंस स्ट्रॉन्ग होना चाहिए और बाकी चीज़ें जैसे कम्युनिकेशन या सॉफ्ट स्किल्स जैसे भी हों चलेगा। और हम भी वही करते हैं, दिन रात मेहनत करके एग्ज़ाम्स क्लियर करते हैं, इंजीनियरिंग कॉलेज तक पहुंचते हैं और जब एक अच्छी जॉब मिलती है लगता है सपना पूरा हो गया। लेकिन जैसे ही हम कॉर्पोरेट वर्ल्ड में कदम रखते हैं स्टोरी पूरी तरह बदल जाती है। वहाँ जाके लगता है मैं तो स्कूल में टॉपर था, फिर ये लोग मुझसे ज़्यादा कॉन्फिडेंट कैसे हैं? मैं तो काम जानता हूँ फिर भी मुझे सीरियसली क्यों नहीं लिया जाता? और वहीं से शुरू होती है वो अंदर की स्ट्रगल। हम चुप हो जाते हैं, अंडर कॉन्फिडेंट फील करते हैं और कंफर्ट के लिए बस अपने जैसे लोग ढूंढने लगते हैं। अगर आपने अभी तक सब्सक्राइब नहीं किया तो ज़रूर कीजिए। यहाँ मैं अपने 20 साल के एक्सपीरियंस से असली स्ट्रगल्स और उनके सिंपल सॉल्यूशंस शेयर करती हूँ, ताकि आप अपनी मेंटल पीस प्रोटेक्ट करते हुए करियर में ग्रो करें। और सबसे ज़रूरी बात, इन स्ट्रगल से हर प्रोफेशनल गुजरता है और मैं खुद भी गुजरी हूँ। करियर के स्टार्ट में ही कुछ लोगों के लिए इंग्लिश स्पीकिंग एक बैरियर बन जाता है। उस पर एक पूरा वीडियो है, अगर आपने नहीं देखा ज़रूर देखिए। और कुछ के लिए शाइनेस और साइलेंस उनके करियर का सबसे बड़ा रोड ब्लॉक बन जाता है। वजह चाहे इंग्लिश हो, शाइनेस हो या ओवरथिंकिंग, चुप रहना आपके करियर के लिए काफ़ी महंगा पड़ सकता है। कॉर्पोरेट वर्ल्ड में कंपटीशन कट थ्रोट होता है। आफ्टर ऑल, कौन नहीं चाहता बेटर सैलरी, फास्टर प्रमोशन, रिस्पेक्ट और एक स्ट्रॉन्ग डेजिग्नेशन। और हाँ, ये सच है, वर्क स्पीक्स, लेकिन सिर्फ काम तभी बोलता है जब आप उसके बारे में बोलते भी हैं। अगर आप चुप रहते हैं तो लोग आपका एडवांटेज ले सकते हैं, आपके आइडियाज का क्रेडिट किसी और के नाम हो जाता है और धीरे धीरे आपको प्रोजेक्ट्स के बैक सीट पर बिठा दिया जाता है बिना आपके कुछ गलत किए। द बेस्ट अप्रोच इज टू डू द गुड वर्क, talk about it, present it confidently so that people know your value. मैं हमेशा कहती हूँ, साइलेंस डजंट सेल इन कॉर्पोरेट। अगर आपने अपनी प्रेजेंस फील नहीं कराई तो आपकी ग्रोथ रुक जाएगी। इसलिए साइलेंस एक रोड ब्लॉक है और किसी भी रोड ब्लॉक को हटाने के लिए एक्शन लेना ही पड़ता है। चलिए देखते हैं क्यों हम चुप हो जाते हैं और इसका सॉल्यूशन क्या है। सबसे कॉमन रीज़न है, लोग क्या सोचेंगे। मीटिंग या डिस्कशन में बोलने से डर लगता है, मैंने कुछ गलत कह दिया तो, क्वेश्चन स्टूपिड लग गया तो।
The payload fairing, or PLF, completes the rocket and provides the aerodynamic shape necessary for the climb to space. On the upper stage in PLF, we'll see logos for Viasat, Atlas, and ULA, as well as the American flag. Well, looking at that beautiful rocket on the pad, I just can't help but take notice of that booster.
Yeah, and one of the things our viewers over the years may have noticed watching Atlas is a large external tube that runs along the outside of roughly the bottom half of the booster. And they may be wondering what that is and why they haven't seen that on other vehicles like on Vulcan before. And the answer to that question actually lies in temperature. You see, that's the liquid oxygen propellant feed line that carries oxygen directly from the top tank to the engines. The thing is, liquid oxygen wants to stay super cold because it boils at minus 300 degrees Fahrenheit.
Oxygen is also the 8th element on the periodic table, which also means it has a lot of kinetic energy, so it naturally wants to be a gas at room temperature. To slow those molecules down, we apply that cold temperature, but then also a little bit of pressure to keep it a liquid.
Yeah, and RP1, our other fuel, on the other hand, is like you and me. It's happy just lounging around at room temperature. So if those two propellants get too close, the RP1 will want to freeze and the liquid oxygen will want to boil and evaporate. So the external feed line is a solution that helps solve that problem. After liftoff, ULA's Atlas V rocket will fly southeast from Space Launch Complex 41. Here's a look at today's flight.
Following final confirmation of rocket readiness, the RD-180 engine and 5 GEM 63 solid rocket boosters ignite to produce more than 2 million pounds of thrust, lifting ULA's Atlas V rocket away from the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Atlas then reaches Mach 1, the speed of sound. The addition of 5 solid rocket boosters, or SRBs, precisely augment the liftoff thrust of the Atlas V, giving it the power to deliver the payload to orbit. With their propellant expired approximately 96 seconds into ascent, the SRBs burn out, followed by jettison. Atlas's guidance system then begins steering towards the precise target in space. The Viasat 3 F2 satellite is encapsulated inside a 5-meter diameter payload fairing, which provides protection to the satellite during ascent. After crossing the Kármán line, entering space, the payload fairing is jettisoned. With the majority of propellant expended stranded fighting against the force of gravity, the RD-180 engine shuts down and the booster stage separates. The rocket then begins second stage flight, weighing less than 7% of what it did at liftoff. With the first burn complete, the Centaur engine shuts down for a coast phase. ULA's high-performance Centaur then performs 2 additional firings of its RL-10 engine. Together, the 3 burns increase the transfer orbit altitude and reduce the orbital inclination relative to the equator. During the third and final burn, Centaur expends all of its cryogenic propellant, minimizing the time to final orbit for Viasat-3 F2. Following the final shutdown of its main engine, Centaur releases the Viasat-3 F2 satellite into geosynchronous transfer orbit, or GTO, to expand and enhance in-flight connectivity for aviation passengers, exceed performance, security, and resiliency for governments, enhance internet experience on board vessels, and help deliver fast, reliable internet to rural communities.
This is Atlas Mission Control at L-9 minutes and 23 seconds. On your screen right now, you're seeing our flight configuration key for today's launch. We have the AV551. The AV stands for Atlas V. The first 5 is for a payload fairing size, which is a 5-meter payload fairing. The middle 5 is for the number of solid rocket boosters, which is fully loaded today at 5. And lastly, we have a 1 for our singular Centaur engine. Now that we've seen the flight plan and learned about the configuration, viewers watching the launch from Florida and parts of the Southeast may be able to see our Atlas rocket in flight. To get a closer look at the visibility map, check out @ULA Launch on social media.
As we approach the opening of our launch window, let's have a look at the weather forecast our launch team just received from Space Launch Delta 45's weather officer, Brian Belson.
Today's forecast for launch is looking good. The probability of violating launch constraints is less than 5%. The ground winds are 3 to 6 knots. The wind direction is east-northeast. The temperature outside is 70 degrees Fahrenheit, and there are no concerns.
L-8 minutes.
And for the team on net 1, we will not be taking the LC switch to ready.
Always had this thought that one day I'll build a small college where students will learn by doing.
So Masters Union in 5 years, where do you think this is headed?
We gave ourselves this target that we want to be a global top 10 ranked institution. I'm speaking Harvard, Wharton, Stanford, Yale, Stern, Sloan, INSEAD, LBS, Northwestern, Chicago. These are the current top 10.
Right.
Every 10 years, top 10 companies on market cap change. Right? NVIDIA was not there.
Yeah.
Enron was there 10 years ago.
Yeah.
It's nowhere now. It's gone. Right? It's gone.
Yeah.
General Motors and General Electric was there. It's nowhere anymore. Now it's all the tech companies.
Yeah.
And the reason the top 10 companies on market cap change every 10 years is because the world is progressing.
Yeah.
The industries are moving forward, right? In education, the top 10 universities have not changed in 100 years.
Wow.
And what that means is that the education system is not evolving, is not changing. When the incumbent keeps winning, that means nothing is changing.
And I don't think the incumbent now offers that safety net, right? So if you go to a Harvard and you spend a lot of money, you're not guaranteed a sort of a placement in the big 4
to an extent, for many people, it will be.
Right.
But I think the world we are going to be living in 4 years from now, will Big Fours even exist? Will employment as a concept exist? I don't know. With agents coming in for everything, I think soon we'll have like multiple billion-dollar companies which will have one employee, the founder.
Hi Ashish, morning.
Hi, good morning.
Good morning, good morning.
What is this?
So, good morning, gentlemen. Welcome to Hilton Gurugram, and
We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, ULA launch conductor Ed Kidda will poll the team for the final go to pick up the countdown. The launch conductor manages the launch team during the countdown, ensuring that all systems are performing nominally and that every member of the team is following their procedure and executing per the planned timeline.
28 engineers are polled to confirm the rocket is ready to proceed. This is a final status check for all Atlas vehicle systems, ground systems, the payload, and the United States Space Force Eastern Range. Let's listen in as he performs the poll. This is Atlas Mission Control at L-5 minutes and 23 seconds. We are currently not hearing a poll because the team is working an issue. Thankfully, our launch window tonight extends 44 minutes, and we will keep on listening in for updates.
As the clock hits 4 minutes here, we are continuing to hold as the team works through this technical issue. We will let you know as we learn more.
This is Atlas Mission Control at L-4 minutes and holding. Earlier in today's broadcast, you may have heard the launch team referring to the range being green. For context, the range, or the Eastern Range, refers to a designated area extending from Florida throughout the southern Atlantic Ocean. The range, operated by the United States Space Force, supports rocket launches from the east coast of the United States. This area is considered and reported to the launch team as green when the flight path is clear of boats or aircraft. In addition to keeping the public safe, the range supports launch providers with communications and telemetry, as well as rocket tracking when in flight and weather forecasting.
What's that smell?
I'm making matcha kulfi for the party.
Oh, that milk is a month old. But the balls are pretty.
Chumbak. Celebrate a life of joy.
Payload itself is designed and manufactured by Viasat, while the satellite is manufactured by Boeing. A lot of people get confused sometimes when they hear payload versus satellite and wonder, what the difference is between those two. The payload is the thing that's actually performing an objective in space. So for example, it's what's providing satellite internet. But the satellite is the thing that provides the payload everything it needs to perform its job, like electricity. So we have these large solar arrays that generate more than 25 kilowatts of power with 144 feet worth of a wingspan, so giant, massive solar arrays to provide that power for that exceptional downlink speed, upwards of 100 megabytes per second. The body of the spacecraft is 24 feet in length to give you a size for scale. And the mass of that payload is actually 6 metric tons for the satellite. So that's going to be probably one of the heaviest spacecraft Atlas has ever launched to GTO.
Viasat is pioneering global technology company, helping transform the world through connectivity. Viasat helps businesses, governments, and communities solve their most demanding connectivity and communication challenges and turn them into strategic advantages. Viasat is creating one of the world's most advanced multi-orbit communication networks to power high-quality, reliable, secure, affordable, fast connections to positively impact people's lives anywhere they are, on the ground, in the air, or sea, all while building a sustainable future in space. The Viasat-3 satellite constellation is an important part of Viasat's global multi-orbit network, designed to add significant capacity that is secure, reliable, and highly flexible. The Viasat-3 constellation is planned to be 3 Ka-band satellites. Each is designed to steer capacity between beams to deliver bandwidth when and where it's needed most, which is important to meet the needs of aviation, maritime, defense, and home internet customers, where the location of high-demand hotspots can change over the course of the day.
This is Atlas Mission Control. Engineers at Cape Canaveral and ULA's Design Center in Denver are working together to develop options to potentially solve this issue for launch tonight. Our launch opportunity remains available through 11:08 p.m. Eastern. This is Atlas Mission Control at L-4 minutes and holding. The ULA team recently launched the first national security mission to ride atop our new Vulcan rocket. Let's take a look at liftoff of this milestone launch.
Permission to launch. Proceeding with the count. Rock, report range status. Range green. Go Vulcan. Go Centaur. Go SF-106.
Liftoff of United Launch Alliance Vulcan rocket carrying USSF-106 from the United States Space Force, continuing ULA's soaring legacy in national security space launch with the innovative Vulcan rocket.
Mach 1, Vulcan supersonic. Vehicles traveling at 1,500 miles per hour, right down center of the range track. Good indication of SOB separation.
This is Atlas Mission Control at L-4 minutes in holding. While we wait for an update from the team, let's take a look and learn more about Viasat.
ओए चलो बस आ गई। यार इसमें तो सांस लेने की भी जगह नहीं है।
जब लाइफ टू मच हो जाए, कैफे स्टाइल कोल्ड कॉफी हो जाए।
खुली हवा के मजे लेते हैं।
Walk on the beach?
I wish I could fly over the beach. Dubai, ready for a surprise?
Viasat Amara takes everything that we were doing as Inmarsat and brings it into the Viasat roadmap of everything we're doing in terms of offering a multi-orbit, multi-network service, coupled with digital product, coupled with monetization, coupled with guaranteed SLAs, everything all together.
So Viasat Amara has really sort of taken what we've been doing for the last 12 years in market and taken that reliability and that brand promise and extending it well into the future. So in the aviation market, our approach to multi-orbit, multi-network is combining Viasat Amara with the new Viasat Era terminal. This allows us to combine the best of both GEO and LEO into one solution and really deliver to the passenger experience.
Along the way, we bring on Telesat, and what Telesat does is it allows you to have a multi-orbit offering so that you can use GEOs, you can use LEOs. What Viasat Era does is take that up another notch by being able to do that simultaneously.
What does simultaneous mean? It means I can get the benefits of GEO with the lowest unit production cost, the highest demand density, coupled with an overlay of low latency applications like, say, first-person gaming. It doesn't matter if I'm scrolling TikTok, watching Netflix. The experience feels natural and contiguous to the customer while we're in the background making packet by packet, moment by moment decisions on how to route that customer's traffic over the best available link to meet that demand. This is big. You know, Viasat Amara was really unlocking our next era of global connectivity. All of our global customers have been wanting that for their global airlines, and it's coming together. So it's really exciting.
Let's take a look a little deeper into more about Viasat.
This is Atlas Mission Control at L-4 minutes and holding. We continue to hold the countdown at T-4 minutes while the team is working on an issue that needs to be resolved before we can proceed with the launch. We'll keep you updated as we learn more.
Elsie, RLN on 1. Go ahead. Okay, picked up another OTC, line item 25. Control booster, logs, Delta P.
Build your dream home with 100% money safety with India's best construction company, Brick and Board.
Roger.
This is Atlas Mission Control at L-4 minutes and holding. Earlier today, our team went out and got this beautiful image of the moon tonight, which some might know is a full moon, but not just any full moon, a supermoon.
And fun fact, this supermoon is actually referred to as a beaver moon, and that term actually comes from the fact that it coincides with the time in the winter that beavers want to, hunker down and settle down in their lodging.
The term supermoon was actually coined in 1979, so it's relatively new, and it just means that the moon can be up to 14% larger tonight than an average full moon. And I believe this one is actually the brightest of the year.
Here are some things you may not know about Viasat. The Viasat-3 constellation is expected to expand and enhance Viasat's Amara in-flight connectivity solution, helping airlines deliver next-level experiences that improve the passenger experience and drive new lines of revenue. For business aviation, it is expected to further elevate Viasat's JetXP solution for an even greater standard of seamless, high-performance connectivity from takeoff to touchdown.
Viasat 3 also offers a clear upgrade path for our maritime customers as a part of Nexus Wave fully managed bonded connection service. This next generation ultra-high capacity, ultra-high speed is designed to significantly enhance the office-like and home-like internet experience on board vessels.
Viasat 3 is also the next generation of commercial SATCOM reimagined for modern mission advantage, delivering high throughput, flexible satellite connectivity that can exceed performance, security, and resiliency requirements for our government partners across land, sea, air, and space.
The Viasat 3 constellation will help deliver fast, reliable internet to more homes and small businesses in rural communities and around the world.
LC flight control.
Go ahead.
I was notified by SYS that we got a contingency Aegis load. Would you like me to go ahead and load that?
Negative.
Copy.
LC, LD, now 1.
LC.
Yes, sir. We are declaring a scrub for today's operations. Please configure for 24-hour recycle.
Roger. SD, LC on 1. Go. At this time, we can go ahead and take the spacecraft back to external power.
Roger.
The Pediashock growth check tool. When I used it for Naira, I was surprised that her growth wasn't quite where it should be for her age. The Pediashock growth check tool helped me track Naira's growth to take the right steps at the right time. Click on the link and try Pediashock growth check tool.
Flight control LC.
Go ahead.
At this time, we're picking up in operation 90, step 20. Terminate option 910 and reset 910 flags.
Roger.
This is Atlas Mission Control. It is confirmed that we will not continue with the Atlas V Viasat-3 F2 launch activities this evening. We have a 24-hour recycle. Our next launch attempt will be tomorrow at 10:16 p.m. Eastern. For up-to-date information, visit ulalaunch.com. I'm Abby Katwar. Thanks for joining us.